The algebra of functions. Given two functions, f and g, then for all the values of x for which both of them are defined, the functions f plus g, f minus g, f times g, and f divided by g are defined as follows. If you add f plus g of x is really f of x plus g of x. F minus g of x is really f of x minus g of x. F times g of x is f of x times g of x, and g of f divided by g of x is f of x divided by g of x, assuming when g of x is not equal to 0. Of course, we cannot have a denominator equal to 0. Remind the condition of g of x not equal 0 is the definition of quotient is restricted to all values of x for which g of x is not 0. Now, that doesn't mean g of x can never be 0, but it can't be, we can't divide when it is 0. So here we've given two functions, f of x equals 2x squared and g of x equals x squared minus 5x minus 6. We're going to find f of x plus g of x. Well, we're just going to add them. So that is f of x, 2x squared, plus g of x squared minus 5x plus 6, or 3x squared minus 5x plus 6. And we're done. Subtracting them, do remember to subtract all of g of x. So f of x is 2x squared minus all of g of x is x squared minus 5x plus 6. Removing the parentheses, 2x squared minus x squared plus 5x minus 6. So we'll end up with x squared plus 5x minus 6. Multiplying them, we'll have 2x squared times x squared minus 5x plus 6, or we'll have 2x to the fourth minus 10x cubed plus 12x squared will be my product. The quotient, we'll have 2x over x squared minus 5x plus 6. And that will be my g of f of x, but we need to give the domain of this. Well, basically, f of x minus 5x plus 6 cannot equal 0. So if I went to factor that, solve it, x minus 3 and x minus 2 would equal 0, x would equal 3, and x would equal 2, but these cannot equal 0, so we cannot have those values. The domain in interval notation will be negative infinity to 2, that being the smaller number, union with between 2 and 3, union with 3 to infinity. That will be the domain. Now we'll do the composition of functions. If f and g are functions, then the composite function or composition of g and f is defined by f of g, or g of f of x, or g of f of x. The domain of g of f is a set of all numbers x in the domain of f, the second one, such that f of x is in the domain of g. We'll work on how to find domains. So here we want to find the composition, and what we're thinking of is our big function is f. So I'm going to put that answer, this answer, into f. Well, if I find g of 2, g of 2 will be 2 over 2, or 1, and then I want to find f of 1. which will be 1 plus 4. So my f of g of 2 equals the square root of 5. Given the same functions, we want to find f of g of 5. So finding the first g of 5 first, the inside one, is 2/5. Then we'll find f of 2/5, or the square root of 2/5 plus 4. Let's see, 4 would be 20/5. So I'll have the square root of 22/5. And we'll want to rationalize that denominator, so we'll take the square root of 5 times the square root of 5. Well, the square root of 110 over 5 will be my f of g of 5. And given us an x value, we'll just have to do it in general. And we're going to find the domain. So starting with the big function f, yeah, I'm going to put the g inside of it. So wherever there's an x here, I'm going to put g. So 2x plus 5 minus 1. Or this turns out to be then the square root of 2x plus 4. Now if we go to the domain here, x minus 1 has to be greater than or equal to 0, so x has to be greater than or equal to 1. But it's not really the f function we're concerned about. It's so much, it's the g. But here we found that x had to be here. This is a linear function, it's all real numbers, but g of x has to satisfy this condition. So 2x plus 5 has to be greater than or equal to 1. 2x is greater than or equal to negative 4, and x is greater than or equal to negative 2 then. So the domain will be from negative 2, the bracket, because it's or equal to infinity. That will be the domain of f of g of x.